Okay. Hi, this is Semantic Find and FileMaker Smarter de-duplication using fuzzy matching. I am David Weiner. I've lived in Portland, Oregon for the past 20 years. I grew up in Los Angeles, so big city. I have a BFA in photography, so not a background in computer science or anything, but I have been working with FileMaker for 27 years. Started as just a user, then moved up to a citizen developer, and then I've been actually a full-time developer for 12 years. I like cooking and gaming, both tabletop and video games. I like travel, so it's been fun coming here to Antwerp, all the way from Portland, and I'm also a musician. So I work currently at Direct Impact Solutions, one of the sponsors at this event. It was founded in Laval, Canada in 1996, which is part of the metro area of Montreal. We have offices in Canada and the US and France and Italy as well. We're a top 5 Claris Platinum partner. Have more than 30 employees and collaborators, including 24 FileMaker certified developers. And we're also an Apple partner, Microsoft partner, and Toka.io. So this session's called Semantic Find and FileMaker, Smarter de-duplication using fuzzy matching. Here's what I'm going to cover today. I'm going to talk a little bit about search in FileMaker. I'm going to go over what fuzzy matching is and how it's defined. I'm going to talk a little bit about messy data and the kinds of messy data we can encounter and why it's difficult to deduplicate it. I'm going to go over exactly how Semantic Find can help improve that kind of searching. I'm going to talk about some specific ways you can apply this to your system. And then hopefully we'll have time. I'll demo a working model of this that I put together. And it's actually pretty cool the way it works. So first of all, is there anybody in here that's not really familiar with Semantic Find? We've heard a lot about it lately, but anybody not know kind of what it is? Okay, seems like everybody does. Anybody that's like a junior developer or mid-level developer, is everyone pretty advanced? Okay, everyone's pretty advanced. Well, I'll kind of breeze through this first part because this is going to be stuff you basically know, but I want to put it all together so it sort of makes sense. First, we're going to talk about searching. So, of course, one of the key reasons that users search in a database is to make sure that if they create a new record, they're not going to be creating a duplicate. So they look for the record they're about to enter, and if they find it, they know not to enter a new one. So in order to prevent a duplicate from being entered, you have to be able to find a likely duplicate. So if you're using the traditional deterministic exact match find, your data has to be more or less identical to what you're searching, as you know. There are ways to drill down and do that kind of search using logical operators, numeric ranges, and wildcards. But at its core, this kind of search really relies on your data to be discrete and relatively clean. So if you search for a date, up comes a record with that exact date. If you search for a customer number, up comes a record with that exact customer number. Likewise, if we want to find a client named Chris Nelson, you enter the first name and last name, and up comes a record with Chris Nelson. However, you're not going to find Chris Nelson if it's spelled with a C, so instead of a K. And as you know, if your user is looking for Chris Nelson because they want to enter this record, they may not be able to find it if it's spelled wrong. Or they have to keep searching until they do find it. So that's kind of a hassle. So also, if numbers are typed in wrong, you're not going to find that customer number. Or if a date has been typed in incorrectly somehow, you're not going to be able to find it. So that's a big limitation with the standard find. So the other type of search that we now have in FileMaker is semantic find, right? So this interprets the meaning of your data and returns the most relevant matching records. So it's what Google does when you search for an article, right? You enter a search query for oranges and tangerines, and you get articles that are related to citrus fruit. So in the context of a database, your typical use case for semantic find might be something like searching the notes field for the customer thinks the cost is too high or something. Or you might search the product description field using Semantic Find to find products that are useful in warm weather. And you might get products like towels, beach towels, bathing suits, sunscreen, right? So that's how Semantic Find kind of works. Both of these types of searches are useful in their own right, but neither is really ideal on its own for finding duplicates. This process of trying to find a duplicate is called entity matching. So I don't know if you've heard the term. Entity matching is a specific sort of process. It's also what we're referring to as fuzzy matching, right? And it really just asks the question, do these two records refer to the same thing? Is this the same as that? It's a really common requirement in many data environments. It's found in healthcare, in finance, CRM systems, e-commerce. You've probably had to do it in your own systems, or your users have, where de-duplication of person, organization, customer data is essential. So it's maybe why you're here at this presentation right now, in fact. So with entity matching, we try to answer questions like, is this new incoming data the same as data that's already in the database? Do these two or more records actually refer to the same thing? Do we have any duplicates in our database that we need to remove or merge? So it turns out it can be quite complicated and difficult to do this. So what is it that makes it so hard? It's messy data. We've all come across this, and data gets messy from a variety of causes. Maybe you've merged disparate databases into one, or you've imported a large amount of data from an outside source, or plain old human error. People don't know how to spell a name properly, so they type it in however they think it's supposed to be, or they actually mistype the names. Or when they can't find what they're looking for, you might hear your users say something like, well, I couldn't find it, so I just made a new record, right? Or, and I've heard this one, it makes me crazy, but, well, I just put in a fake record for now because I couldn't find the real record, and I'll just clean it up later. So, then you have like duplicates all over the place, and they're named different ways, and it doesn't make any sense. So, anytime our data varies slightly from like misspellings or alternate spellings or abbreviations, it becomes really hard to search for and identify a match between two records. So messy data like this doesn't only make deduplication more difficult, it actually causes duplication in your database. So tons of examples of the kind of data that gets messy and can cause problems. I'm going to just go through a couple real fast because these are things we've all seen, but names can be misspelled. There's nicknames or different spellings depending on the language. Addresses can be written in different ways or with abbreviations. Dates can be typed incorrectly, or perhaps you're using the American versus European format. You may have value transpositions, or somebody just clicked the wrong calendar day in a drop-down. Organizations can be written differently depending on legal names, the common names, abbreviations again. And product descriptions might be entered all kinds of different ways without some sort of strict standardization. So these sorts of mistakes cause a lot of duplication in a database. Because, of course, when a user who's entering data can't find what they're looking for, they probably just enter a duplicate. They just enter it the best they can. So if our problem is that we need to deduplicate and clean up our data, we need to be able to find those duplicates. And, of course, there are ways to hand code fuzzy matching or entity matching to some extent in just regular FileMaker scripting. It's pretty tedious, and there's always situations that you can't account for, that you will miss. This is where Semantic Find comes in. So using the semantic search tools in FileMaker, we can much more easily identify when two records are a match, and when the data is messy still. And it can also help us identify records that are not a good match. So how do we actually do this? I'm not going to go into too much detail about how to set up your file for Semantic Find, because you guys probably know much about that, and there's also a lot of great resources that explain how to do that. But I am going to show you how to set up Semantic Find specifically for fuzzy matching. So first thing you need to do is create vector embeddings, which we heard talked about a lot this morning in the keynote. The vector embedding is a numerical representation of your data. As you can see here, that's just data in numbers. It's stored as binary data in container fields is the best way to store it. And then Semantic Find compares a vector of your search query with these vectors of all of your data, and it returns a similarity score for each match. So you need to decide what data you'd like to search for fuzzy matching. And then you create embeddings of that data in all of your records. And this is sort of basic stuff you have to do for any Semantic Find setup. So again, I'm not going to go into too much detail about how you create and store these embeddings. But there are some considerations specific to fuzzy matching that are a bit different from normal Semantic Find. So how do we choose the fields that we want to search on? Well, with ordinary Semantic Find, you're matching against the meaning of text. But with entity matching, we're really just matching against the similarity of the actual words. There are embedding models that are tuned specifically for text similarity. And those are the kinds of models that you want to use for your embeddings. But so we want to match Chris Nelson with a C, not with several paragraphs about Chris Nelson's life. So it's a little different in the way that the Semantic Find is going to be working. This being the case, we only need to create vector embeddings for a selection of fields used for matching. So there's any number of ways you might approach this, but the method I've used with success is to create a calculated field, like a concatenated field of a short match phrase that, if identical to your search query, would represent a perfect match. So if you're searching for a person, you might create a calculation field consisting of first, middle, and last name, and date of birth. If you're searching for an organization, you might use organization name, address, and phone number. For a product in a catalog, you might use item name, item description, and size. So what you're doing is you're choosing good identifiers that might vary slightly and throw you off the trail when you're trying to find that. So once you've set up your file with an embedding model, and you've chosen your match fields, and then created vector embeddings for them, the actual steps for fuzzy matching go like this. Step one is blocking. This is a standard step in entity matching, not just in FileMaker, but in other large data sets that also have to do this kind of thing. And it aims to reduce the size of your initial found set. And you use a regular FileMaker search to do this part, and you search on a single field, preferably one that relates to your match phrase in some way. And we'll go over this in more detail in a second. Step two is actually performing Semantic Find. You're performing Semantic Find on this smaller set of records to look for a match with your match phrase. Step three is that you repeat these two first steps several times. And you're blocking on a different match field each time. And then you append the new results from the Semantic Find to your total results. And then step four is that you process your results after the end of this looping. And you would process those results according to whatever business rules you have. So we'll talk about step one, blocking, first. Because Semantic Find performance can be pretty slow against large data sets, it's generally necessary to reduce the size of your initial found set. This isn't as applicable if you're doing this with a small data set. If you've just got 1,500 records, blocking isn't going to offer you a whole lot of benefit. But when you've got a big data set, more than 100,000, 200,000, 500,000 records that you're searching through, this is essential. So this is a kind of a standard practice. It just reduces the number of records that you actually have to search through using Semantic Find. you basically want to create a group of records that have a higher likelihood of containing a match to your query. So to follow our Chris Nelson example, we might start off blocking on the first name field. So we perform a standard FileMaker search for records with the first name Chris. And we end up with a found set of 1,251 records. Now we move on to step 2, and we perform a semantic find on that whole match phrase. And so we're searching first, middle, last name, and date of birth using our embeddings. And this time, we only find 2 matches with a high cosine similarity. So this means that with Semantic Find, we located 2 records in that found set of 1,251 that had a closely matched first, middle, last name, and date of birth. So the interesting thing here is that those 2 records we found were exactly matched to a portion of the search query, which was the first name. And then the fuzzy match was to the rest of the search query, if you follow. So it takes significantly less time to perform a semantic find against 1,200 records than it does against 500,000. So this process is kind of essential with larger data sets. So now we move on to step 3, which is to repeat the blocking and semantic find process. The second time around, we might perform our blocking for records with the last name Nelson. And we end up with a found set of 408 records. So performing a semantic find pass on that smaller set results in only 1 matched record with a high cosine similarity. We store that result with our first 2 results, and we make another 2 passes, blocking on records that have the same birth year, perhaps, and perhaps the same phone number prefix. And after all of these passes, we now have a JSON variable containing 4 high cosine similarity matches to process. And that's going to look something like this. We've got your record IDs, and you've got a similarity score on the right. The similarity score tells you how close the vector embeddings were to each other and gives a good indication of whether you have a likely match. While all LLMs have some variation of the ones that I've tested that return the best results, which is Gemini, OpenAI, and one called Gina AI, which is specifically tuned for text similarity. A cosine similarity below about 85 doesn't really seem to be that useful for entity matching. So what you do with these results depends on your specific use case, of course. Since the purpose of entity matching is to search for duplicates, handling them will depend on your business logic. So some practical applications you might consider for this kind of AI-assisted search. So we can do things like bring up a list of possible matching person records before entering a new person, even when the name is spelled slightly differently, so we avoid duplicates. It brings up something with a high cosine similarity, and you go, are these matches for what you're looking for? We can also use the same approach for organization names or addresses, or when adding something like a new stock item. Do we already have an item like this in stock, or should we add this as a new one? Semantic Find can also be used to build a de-duplication module that runs on your server every evening, automatically merging newly created records that might be identified as duplicates if the match percentage is higher than a certain amount. Or perhaps instead of actually merging them, it just flags them. And so the next morning somebody reviews, oh, we may have had some duplicates created yesterday. Or we could create an alert for users when they're about to add a new record that may already exist. This looks like a record you already entered. Are you sure you'd like to add this new one? So lots of different ways that you can incorporate this kind of semantic find, de-duplication, entity matching stuff to improve your search results and help make de-duplication more accurate. And it's kind of the first time we've been able to easily do something like this in FileMaker, so it's pretty exciting to me for the possibilities. And now I'll actually show you the stuff that I have been working on. and what inspired me to even want to come and do this presentation for you guys. So I think I've got to switch, and we have another 10 minutes. Switch to mirroring mode. Nope. There it is. Okay. Okay. So the inspiration for this, I work a lot with public health data. It's the primary client that I work with. And we regularly, daily ingest hundreds, if not thousands, of lab reports from around the state for, communicable diseases. And when those lab reports come in, one of the first things we have to do is figure out, do we already have the person listed on this lab report in our system? And so over years, we built this whole long, scripted process that goes, well, let me compare names, first name, last name, date of birth. Oh, we didn't find that, so let's try a different way of searching. Oh, let's try flipping the first name and the last name. Let's try slightly different, it's the whole thing, and it's difficult. It works reasonably well because we've really tweaked it over years, but that's a lot of work that we put into that. And I built this from scratch without even knowing if it would work, but just to try and test it out in about 40 hours. So, and so the process here was inspired by, you see it says patients up here. This was patient data coming in, and then we want to try and find a match for that. And over here on the right is a list of, this is where it's searching in this, and this is about 104,000 records. On this process, this semantic search happens on the server, which is going to be a lot faster. So you can see here there's two methods. Method one is the one I've got the most success with, and I'll go over it in a second, how they work slightly differently. But what we're doing is we're taking the first name, middle initial, last name, and the date of birth. That's our search phrase, and when this incoming data arrives, we quickly create a vector embedding for that set. We put it in a global field, and then we use that as our comparison for semantic find. So if we run the search, you can see it brought up a match here. And you can also see that the names are spelled differently. And in fact, not only that, but the dates of birth are completely different. So somebody wrote in 2/11/87 as the date of birth. Here it's 11/2/87. The last name is not spelled the same. The first name is not spelled the same. And yet we still came up with a 93% accuracy. So it goes, this is probably a match. This is, by the way, this is using the Gemini embeddings, and in order to create the embedding on the fly for this, but also there's a set of records that have Gemini embeddings. And I've got another set of embeddings in the same table for a local model that is actually installed on our server. So for like public health data, we can't have personally identifiable data being sent out to OpenAI or Google. So it is essential to have an internal large language model. So you can see if I toggle the model to the local one, it actually will do pretty well as well. Also came up with it. And here's, you'll see here, this one though came up with 84%. So they do operate slightly differently. If I change the first name, oh, and also it's looking, so we don't even have the middle initial. So if I hit this again, it should come up with a slightly higher score. So now it's scored it at 87. Oh, and look, it found another person with a similar name. Oh, and actually, this one came up at 87, and that's because this one has a different birth date, but has the same middle initial. So the interesting thing is to start to play around with the names and the dates of birth and see how much you can change it before it drops out of like being a good match. And I've also set it up here so we can look at we can change the threshold, and which is the sort of score at which we go like, I don't want to see anything that's below 80, right? 85, as I said, is about where it starts to get good. Below 85 is not a great match, and you'll see some of these. So here's another one. If we do this search, we've got 93% likelihood that this one is the same, but as you can see, the date, the year date is wrong. And the last name is spelled incorrectly. So if we change this to a different spelling, can we still find it? Yeah, and it's 89%, so it's getting a little bit lower. And if we change everything to match identically, it will give us, it should give us 100%. So if we search again, now it's at 90% because now we've got an accurate birth date. But just what made me really excited about this is the fact that you can have several pieces of data that are not accurate, that you would not be able to find with a standard FileMaker search without like going the first 3 letters then an asterisk, or looking for everybody with the first name, Luella, and then searching through that list. And is there anybody with a similar name or similar date of birth? But this can just do that for you. And I don't know if anybody have to do this kind of process manually, but it's a pain. Here's another one where we've got Emily Mikuszewski. The last name is probably sounds the same, but it's misspelled completely. And we still were able to find it, which to me is kind of amazing. And this one now has a similar first name, same middle initial, but different last name, and you'll notice that the score is only 81%. And there's lots of examples of some of this stuff where you can change certain things and you'll see the score go up or down, and so you can kind of test. And if we reduce the threshold here to like 7 to 70, whoops, has to be 0.7, and then we search, you'll probably see a whole bunch of results that just aren't very good. So we've got 99%. So we actually found this person with almost the same name. They just didn't have the middle initial. But these other ones, like Harold E. Coyle, I don't know why it found this, maybe because of the same birth year, but 79% is, this is obviously not a match. And sometimes, the way that AI and large language models can become a little mysterious. Every once in a while, you come across something and you're like, why did it even show me this one? This doesn't seem like at all similar. But which is why I say above 85% seems to be pretty good. And if we switch this back to 0.8. So this one, I'll show you now the method 2, which is slightly different. Method 1 just uses the first name, middle initial, last name, date of birth as our match phrase. Method 2 adds more information. It adds phone number and address data as well. And in some ways, it is a little bit more accurate because you're searching more data. And so if you consistently have all of that data, this might be a good way to identify a match. However, it can introduce like noise. So if I go method 2, what will happen is we'll have some other ones in here that are like not great matches, and it's because they may not be similar in the name and the date of birth, but they've got similar address data. And so that's where the sort of noise has been introduced. So if you can reduce it to sort of distill your match phrase down to the most important identifiers and keep it pretty short, then I find that the results are kind of more accurate. You won't have as many sort of false positives. And like if we change the spelling, we can kind of play around and see if we change the spelling of this and like how far away can we get before it can't find it anymore. It was at 99%. Now we're at 92%. So it still was able to find this person. If we change the date of birth, can we still find them? Yep, 90%. So it can kind of, like the large language model kind of, in the same way that if you and I looked at these two records and went, oh, look, somebody just misspelled the first and last name. And also, they messed up the date of birth, but I'm pretty sure this is the same person, right? But like, you can't do that with a regular FileMaker search. humans can look at that sort of pattern recognition, and we can understand that somebody just typed it in wrong. And they both of the models that I've used have a similar, pretty similar outcome, 93%. And it's still, to me, it's kind of amazing, and how well it kind of works. So I think we have. Looks like we're done. If there are any quick questions, I can answer some. But other than that, thank you very much for listening.
Thank you. That's a really great method to identify these duplicates. But now comes the practical question: when you have identified, how do you know which one is the correct? Is there some kind of business rule or some quality score behind it that you can decide which one to keep and which one to join?
I mean, yes, I think that sort of depends on what kinds of duplicates you have, what scores you come up with, how many duplicates. If you are, if you're looking through a database of hundreds of thousands of person records and you come up with one match that's 94%, you could maybe safely go, yes, I think we're just going to trust that that is a duplicate and we'll merge them automatically. Or, maybe you're just doing something like showing the user, hey, we may have found some duplicates. What do you want to do with this? And you can let the user choose. Or, like I said, if you're doing something automatically, maybe what you're doing is you're just flagging them on the server each night. And somebody in the morning goes like, oh, are these duplicates? And makes that determination. But it really depends. If you've got 30 duplicates that are all a high score, then you don't want to automatically do anything with that. Or maybe you do a secondary check. I've got a 94% match, but what does the address data look like? Is it also a match? And then you can kind of do like a secondary, maybe standard FileMaker search to just see, do we have any other matching data in this record to confirm,
Okay, I see. Thank you.
Yeah.
Just one point. So the first cut, if you like, there has got to be at least one of those your fields has got to match. Otherwise, they will be completely out of the loop. Full stop.
The blocking?
Yes, the blocking.
Yeah. So blocking, the blocking sort of part is it sort of requires some careful consideration, right? If you are blocking, say, 4 times, right, and you're blocking on first name, last name, date of birth, or year of birth, or something, and the first 5 digits of a phone number, if you can't find a match by doing a regular FileMaker find for any of those, then maybe this is not a good record that you're going to be able to find, right?
Yeah, I think that you probably answered my question there, which was if you do the date of birth, then you've got the entire date of birth. But
Right.
if you take the year out of that, or like you say, the first 5 numbers of the phone number, you've probably got a better chance of.
Yeah. So you want to, and that takes a little tuning, a little playing around with to get sort of the results that, you have to do some testing and go like, I know there's a duplicate in here. Why am I not finding it? Oh, because if all 4 of your match pieces of data are not identical, then they will never come up in one of those subsets during blocking. So you want to try and enable yourself to find, those likely matches by assuming that at least some of the data you have should be good. If it's all bad, then maybe you're just out of luck.
So I have a couple questions. Have you tried Perform Script on server to see if that actually works effectively in our huge set of records? That's part 1.
This is performed on server.
Oh, okay.
In fact, this is performed on a server that we set up. We've upgraded it so that it's good at doing semantic find pretty fast. It's got a GPU. It is like an AI server. It's not one of the more expensive ones because it's just doing embedding and semantic find. But this server also that this is hosted on is in the eastern United States. So we're going all the way across the Atlantic, and it's running pretty fast. In fact, this last search was under a second to get the results.
Good to know. So, but still, even on that server, if you're searching on the 300,000 names, it does not perform it?
Well, you don't want to do just a semantic find on the entire
Yeah,
set of
yeah,
300,000.
yeah,
Yeah.
I mean, you do because if you're, like in his example, if you're missing data, like if the record you have doesn't have a date of birth, or doesn't have a
Yeah.
phone number, or doesn't have something, or if someone's a twin, or there's a maiden name, or something like that,
Yeah.
then if the blocking fails, then the whole thing fails.
Then, yeah, if the blocking fails, then you are out of luck. I mean,
Yeah, but if you do the semantic search on the whole set, then you solve that problem.
yes. Blocking is not something specific for FileMaker, like entity matching in the larger world of entity matching. They also do this because it's an efficiency. You don't need to search on records that have no relation whatsoever to what you're looking for, right? So you try and eliminate a set of, like, the largest amount of records you can while still capturing probably what you're looking for. And that's the idea. You do have to kind of, there's a play between efficiency and accuracy that you have to kind of consider when you're deciding what to block on.
I haven't tried it with that large of sets, but anyway, so I was curious.
Yeah,
The second thing is, you've tried a bunch of models, many more than I have for this. Is there performance data for the different models that you use for the search screen?
In fact, on the Hugging Face website, they have what they call a leaderboard for embedding tasks. They probably have it for other like models, how they perform. But it's like a leaderboard that literally like is how well did the Gemini embedding perform versus OpenAI versus Cohere and all the other ones.
On the search part is what I'm really curious about. Is that the same, or is it?
Oh.
Yeah, I don't care about the embedding speed so much, I think, but
well, the embedding, it's not the speed.
The speed of the actual search, when you do the semantic find, does that matter what model you're using?
It shouldn't really, no. I mean, what I've noticed is that the Gemini is a little faster because it's Google's servers, but this uses an insert from URL. It's sending out a small piece of data and getting back embeddings.
Well, yeah, but when you're doing the search, you're actually not making an AI call.
No. Well, you do because you need to initially vector embed your search query, but that's just one little.
Okay, so you're doing a vector to vector as opposed to natural language.
Yeah.
Okay, because that is known to be faster.
Yeah.
Okay, but even still, then, so
I haven't really noticed a huge difference. The local one seems to be a little slower to search, slightly slower, but it's not a dramatic amount. Although every once in a while you do a search and you're like, why did that take so long? I have no idea. Maybe because one of the blocking sets was particularly large. Oh, in fact, I have a John Smith in my test bed here. And when we run this one, it goes pretty slow. And I think because there's a lot of Johns and there's a lot of Smiths in the database. And so that's the only reason. Oh, you know what? I have the wrong set. I have a set flagged, and it's in that set, so. If I do a search on John Smith, I'll have like 10,000 records. It's in here somewhere. John Smith. So if I do this one, method 1. Oh, that was pretty fast. Oh, wrong record. Wait, what happened? It got switched. Oh, it was a lag time in my, okay. So that one took 1 second, but this one will take not too long, 1.74 seconds, so not too bad. That was Gemini. If I toggle the model to the local one on the server, records remaining to delete. Oh, so so the way that this works is it actually, when it finds matches, it creates a join records between this table and the person table so that you can see them. Apparently, there was a lot of join records to delete. Or it's just getting tired of calling all the way across the Atlantic Ocean. So that one was still pretty fast, actually. Earlier, it was a lot slower, so maybe everything is performing better at the moment. But you can see lots of John Smiths, lots of fairly high scores. So some of these, you'd have to kind of make a judgment, like Johnny L. Smith, February 16th, 1965. This is probably the one. It's pretty much a match. But John G. Smith, born in 1975, still says it's 90%. I would say that that's not a good result. It's not really, if it's that far off, I don't know. So you do have to kind of make some judgments about how to. Sorry?
10 years off is a one-letter typo.
Yeah, it's true. It's true. So that is a good point, actually. So the interesting thing, too, about the small sort of just a few fields, you're creating a big mathematical vector of just a few things. So it's actually a lot lower noise than you would have if you're embedding like a large text block. And so my sense is that it's pretty good at getting some pretty accurate results when it's comparing these two things, because it's not comparing, you know, a sentence to a giant block of text. It's comparing a sentence to a sentence. And so they can be a lot closer, and it works quite well, honestly. You know, this is person data, but you can also set this up for kind of any kind of data that you need to be doing this kind of thing for.
Would it make sense to make a combined key of very few informations and use that as a blocking, for instance, say first letter, first name, first letter, last name, and some really simple data where you think that's probably you know, precise, and use that as a blocking data?
So like first find every record that starts with a J. You could, your sets of records.
Well, perhaps two, you know, like if it was John Smith, then it was JS, and, you know.
Yeah.
So you build it up like that.
Yeah, you could. The potential problem there is that you might come up with way more records that you have to search via Semantic Find. And so there's the trade-off. Like, if you want to make sure that you have a large set to search through because you don't want to miss any possible matches, then you can block on a larger set, but it's going to be slower because you now have to do your Semantic Find against a larger set. So there's a trade-off between what's efficient and what's accurate, you know. So, and that's, you kind of have to play with that. Yeah. Any other questions? Cool. Well, thank you very much. Appreciate it.